Assalamualaikum warahmatullahi wabarakatuh and good day. My name is Omar Abu Hassan.
Now we're going to look into boost converter. Basically, compared to buck converter, boost converter is the average output for the boost converter is higher than input voltage lah. So compared to buck converter, the output is less than input. So basically step down lah. So for boost converter is basically we step up from the input. So from the input, we want to increase it to another value. So power stage also conceive the same component as a buck converter. So you have three components: inductor, switch, and also diode. The difference between buck and boost is in the buck, we put the switches in here, uh, and the diode over here, and the inductor is on here. Later on, we will compare about it. Okay, so in boost converter, we put the inductor over here near to the supply, and then the switches in here, and then the diode near to the load. Okay, so in terms of the performance of boost converter, uh, the input current characteristic is good, but output is bad. Bad mean in terms of the ripple. So basically, if we want the output of our power converter to be smooth and less noise, but whenever um, uh, we use boost converter, the ripple sometimes is very high, so it's causing the noise lah. Okay. Okay. So let's compare. Let me try to draw. Okay. So we have buck. Oops, buck. So for buck converter, try. Let me see. Okay, saya tak boleh nak. Alright, down here. Oh, it's okay. Let me try. Okay, for buck converter, we have the supply here. Bukan buck lah. Kita let's say overall lah. Overall converter, we're going to have the supply part, and then in here is we call it power stage lah. Power stage. So the two power stage. Stage, and then we have output side load, and then sometimes we put the capacitor over here to stabilize our output. So this is supply side, supply, and then this one is load, load side. Okay. So for the buck converter, we have inside here we have something like this. Start with switch. Okay, start with a switch, and then we have inductor over here, and then the diode. Like this. Okay. So we start with a switch here, S, and then L, and then this one is D, diode. This one is for buck converter. For boost, the arrangement is slightly different. We start with the inductor over here. Oops. We start with the inductor, yeah? Inductor, and then diode, and then we put the switch over here. Okay. Okay. So this is the one that um, this one we paste input in here. Okay. Okay. Previously in buck converter, we use this arrangement. Okay. We use this arrangement inside the power stage. But for the boost converter, we arrange our inductor, our diode, and our switch into here. So what's the difference? So okay, let's see in the what you call it in during the on and off cycle. So during the switch on, whenever we switch on our switch in here, okay, so when we switch the this supply, this switch, the the voltage supply will circulate into this inductor and then passing through a switch and then return back to the supplier. So the circle over here, we circle this one. That means the supply will charging the inductor current in here. So that one is during the switch on, during the switch on. So during the switch on, diode will be reverse bias. So this the diode will be open circuit. And the input is disconnected from the output. That means the output is separated from the input side. From the input side. So the output basically zero lah, ataupun putus lah. So there is no energy flow from the input to the output. So output get the energy from the capacitor only. So output only get the supply from the capacitor. That one after the first cycle lah. So basically when we start our system, our power converter, it takes time to stabilize, to reach the steady state charging. So whenever after steady state, so when the switch is closed, output will be separated from the input, and the output will get the supply only from this capacitor. So during that time, the capacitor will be discharging lah, and drop. Okay, so during the switch close, Vs and V supply, V inductor will be equal to Vs. So we will have our model is VL on will be equals to V supply, Vs. This one, this one. So why this one is important? Because we want to come out with the transfer function. So the relation between V out and Vs. Same with the inilah buck converter lah, kita nak ada model. So easier for us to whenever we want to determine our, okay, let's say whenever we want to design our boost converter, there will be a specific value of output voltage, right? For example, our input is 5 volt, and then our output that we require is, let's say, 9 volt. So then we can calculate how much our duty cycle for our boost converter. So basically we need to have that model. Okay, so this one is during the switch on. Okay, next we're going to look into the state, the condition during the switch off. So when the switch is off, the output will be connected to the input, and the diode is forward bias. That means short circuit. Diode is short circuit. So the output will get the supply from input voltage Vs as well as VL. So so this is the model for our ni lah, our um, V out. So Vs is equal to VL plus V out. So so then VL off. So this is the VL off. VL off is equals to Vs minus V out. So V out we move to the side lah. So we get VL off equals to Vs minus V out. Okay. Okay. So then from that we can get the transfer function. So this one is during the switch off, switch close. During switch close, we know that VL is equal to L dIL dt. So that's mean we can get the delta IL is equals to Vs per L time with dt. This one. This is the model that we want. Basically from this one, kalau if you not understand how we get this one, let me know. I will show you. But it's similar to the buck converter. So first we replace this VL with this one. Okay, and then we get this one. Where L, this inductor value, we move to the Vs side. So that's why it's over. Because kalau kat sini darab, bila kita pindah ke sebelah, it will get kena bahagilah. We have to divide. That's why. Then from that we move this one dt to the side. That's why dia darab lah. Dt kat sini bahagi, move to this side, we have to multiply. So that's why jadi inilah darab dt. So we have this transfer function delta IL close during the switch on is equal to Vs over L times with dt. This one is during the charging process. During the switch on, maknanya in here. So this one is dt, and during the discharging process is 1 minus d time with t. Time with t. So kalau kita tengok, let's have a look on this one. Okay. So during the switch off, kita open circuit this one. So diode is fault bias, close. So the power will move here. We circulate over here. So that means V out is equals to Vs is equal to VL plus V out. So V out is equals to, so using that actually, so VL is equals to Vs minus V out lah. This one. So same, replace VL with LdIL dt. So we will get this. We got this. So from this, then we can rearrange to get this one, where the DIL is we change to the delta IL. Delta IL means delta IL open is the current during the discharging. This side. This one is number 2. Number 1 is during charging process, during the charging. So the delta IL open is during this one, where Vs minus V out over L. So sama juga, L we have to divide, and then times with 1 minus D times T. This one, this masa lah during the discharging. Okay, so from that, then we know that during the steady state operation, the current charging and discharging, the total of current during this charging and discharging will be equals to 0. So delta IL close plus delta IL open will be equals to 0. Then both, so this one we use first model, and this one we use second model. So if we combine both of this, we will then we rearrange the model. We will get this V out is equals to Vs minus V out is equal to Vs over 1 minus D lah. So that's mean uh, the maximum duty cycle is 1. So, but we cannot go to 1, right? So because 1 minus 1 is equals to 0, right? So, and Vs minus 0, infinity. So, so usually when we design the boost converter, we have to set our limit lah of the duty cycle, probably around 0.7, 0.8, 0.9, something like that lah. We cannot, we not go into uh, small value, meaning 1 minus D is cannot be too small lah. Otherwise, our the difference between input voltage and output voltage will be very large, and the then the problem is at the component of our boost converter lah. So usually we set our limit maybe 50% different between input and output. Yeah. Okay, so up to this, any question? So this one just to get our transfer function for V out. I mean the relation between output voltage and the input voltage. Okay.